indices. This indices is from the word index, that is power. For instance, if I say 4 raised to power 2, this is, we see that 2 is a power of 4. So, and this is index of 16. Now, for these indices, we need the laws in order to tackle indices. The first one says a raised to power m times a raised to power n is equal to a raised to power m plus n. This a, we call it the base. So if they have the same base and different powers and want to multiply them, the law says it is equal to the base raised to power, you add up the powers. For instance, let's say we have 3 raised to power 2 times 3 raised to power 5 and want to multiply it, the answer will be 3 raised to power 2 plus 5, and that is 3 raised to power 7. We can only do this by adding up the powers when we have the same base. As you can see, there's 3 here, there's 3 here. But if you have something like this, let's say 2 raised to power 3 times 5 raised to power 2. Here, they don't have the same base. This and this are not the same, so we cannot apply the law here. So, but when you have something like this, 2 raised to power 3 times another 2 raised to power 7, the law says it will be 2 raised to power 3 plus 7. So that is that. Another one says a raised to power m divided by a raised to power n is equal to this. As we have it under division, if it as you have it under multiplication, that the power becomes addition. When you have the division, the law says you subtract. For instance, you have 2 raised to power 5 divided by 2 raised to power 2. So this is just 2 raised to power 5 minus 2. That is this minus this. So that is 2 raised to power 5 minus 2 will give me 3. So that is that about that. Another important law is a raised to power m, then raised to power n is equal to a raised to power mn. What this thing simply means is that if a base, a number, is having 2 powers at the same time, m and n, the law says we should multiply. For instance, if you have 2 raised to power 3, also it is raising to power, let's say 4, the law says I should multiply the powers. You can see this is a single number that is having 2 powers at the same time. So you multiply 3 times 4 will give me 12. So that is what the law says. And another one says AB raised to power n equal to a raised to power n dot b raised to power n. And what this thing is saying is that if you have AB means A times B. If you have 2 numbers in multiplication, both of them having this power, you can separate the power on both, on A and on B. You can see A raised to power n, B raised to power n. For instance, let's say you have 2 times 3 raised to power 5. The law says it is 2 raised to power 5 times 3 raised to power 5. The same thing goes to the division. If it is division, something like this, let's say 2 over 3 raised to power 5, the law says it will be 2 raised to power 5 over 3 raised to power 5. You separate the powers on both. Okay, that is that about that. Another one says a raised to power 0 equal to 1. So that is any number raising to power 0 will be equal to 1. So e.g. 2 raised to power 0 is 1, 5 raised to power 0 is 1, x raised to power 0 is 1. That is what this law is talking about. Now, another important law says a raised to power 1 over n is same thing as nth root of a. When you have a number having fraction as a base, reciprocal 1 over something, so the rule says it is root, nth root, whatever that is here, the root of this number. So e.g. a raised to power half is root of a. So I would have put 2 here, but since it's 2, we don't put 2 there. But if you have something like this, let's say 1 over 3, so this will be cube root of a, something like that. So 5 raised to power half simply means square root of 5. So 5 raised to power 1 over 4 will simply means 4th root of 5. And another important one from this place is a raised to power m divided by n. If we have a number at the numerator and another number at the denominator, both powers of a, so this is a raised to power m raised to power n, so which will now become this nth root of a raised to power m, or we write it as nth root of a all raised to power m. What this thing is saying is that if you have a number raising to power fraction, this numerator here is the power of this a, while this denominator is a root. As you can see it here, that the denominator is nth root of a, then a raised to power m. M is the power of a. So for instance, let's say you have 3 raised to power 2 divided by 5. So firstly, over 5 means 5th root, then 5th root of 3. This 2 here is the power of 3, so I'll put 2 here. So that is what the law is saying. Another important one is this: a raised to power minus n is equal to 1 over a raised to power n. That is, if a number is having power of negative, it's same thing as reciprocal. So for instance, if you have 2 raised to power minus 2, it's same thing as 1 over 2 raised to power 2. That is what the law is saying. But if you have something like this, 2 raised to power minus 1, is same thing as 1 over 2 raised to power 1. But we don't need to put this one. So it simply means 1 over 2 means 2 raised to power minus 1. So similarly, I can say that 1 over 5 simply means 5 raised to power minus 1. So that is for this law. So let us take an example on this. So here, we want to simplify this. So the numbers we have at the base are 3, 2, and 5. As you can see, those are the base 3, 5, 2. So this 3 here, it is ordinary 3. So we can put it as 3 raised to power 1. Now, according to the law of indices, the first one, which says if you have this, a raised to power m times a raised to power n is this. That is, if you are multiplying, you add up the powers. As you can see here, that we are, let's take the 3 first. I am multiplying this and this, so I will add the powers. The power of this one is 2. I'm multiplying to this one, so it will be added to the power, which is 1. There's another 3 here, but this 3 is at the division, so it will be minus the power because we are dividing, so we have to subtract its own power. Now let me take the 5 next. 5, what we have here is minus 3. So where we have 5 again is this place. So because it is division, I'll put minus. There is minus 4 here. That is the power of this one. This first minus is because we are dividing. That is why we are minusing this power. But now we have another negative from the power, so therefore this will become plus. Finally, for 2, I'll have 2 raised to power 4. This is dividing this, that is minus 3. You subtract the powers because we have division. Here will become 2 plus 1 is 3. 3 minus 3 is 0, times 5 raised to power minus 3 plus 4, that is 1, times 2 raised to power 4 minus 3, that is 1. We know that 3 raised to power 0 is 1. 5 raised to power 1 is 5. 2 raised to power 1 is 2. 3 raised to power 0, we have said that any number raising to power 0 is 1. So if you multiply this, it will give you 10. So 10 is our answer. Let's take another example. But before we continue with our example, let's consider these numbers and their indices. So we know that 4 is 2 squared. We should take note of all this. They are very useful when it comes to the knowledge of indices. 4 is 2 squared. 8 is 2 cubed, like that. We should take note of them. You can see, as you can see them. You can see them. So take note. We'll be using all this in our subsequent examples. Now, let's take another example. Another example now, we want to simplify this. In order to simplify this, we need to know the index of all this number. The index of this, index of this. This one is already in its index form. Now, we start by writing this, the index of 4. We know that from what we have given the other time, we know that the index of 4 is 2 squared. Then raised to power 3. This is the 4. Then raised to power 3. Then times the index of 9. That one is 3 squared. But there is a power there of need before, which is minus 2. Then times 2 raised to power minus 4. Then all over 16 will give me 2 raised to power 4 by index. So we have given the other time, this is index 2 raised to power 4. We need to memorize it. Then this is for 16. The power on it is minus 2. Then times 27 is 3 raised to power 3. There's another number there, which is 3. Then times 3 raised to power minus 5. So from this place, we multiply the powers by the law of indices. Multiply the powers. 2 times 3, that is 6, times 2 times minus 2, this is minus 4, times this one will give me 2 raised to power minus 4 over this one will give me 2 raised to power. We multiply the powers. 4 times minus 2, that is minus 8. 3 times 3, that is 9, times 3 raised to power minus 5. Now, we have two numbers here. We have only 2 and 3. 2 and 3. So we apply indices, which says if you are multiplying, you add up the powers. You have 2 raised to power 6. You are multiplying it with this one. So since we are multiplying, I'll put plus there. Plus its own power. Its own power is minus 4. This is another 2 here. We are dividing now. So since we are dividing, I'll put minus. Minus its own power. This is its own power. Minus 8. Now let's move to 3. Times 3 raised to power minus 4 starts there. We are dividing it by this. Since we are dividing it by this, it will be minus its own power. This is its own power. We are also dividing it by this. It has to be minus its own power. That is this. So this will now become 2 raised to power. This is plus and minus. Plus times minus will give me minus. There is 4 there. Minus, double minus here will become plus. This is 8 times 2 raised to power. This is minus 4, minus 9, minus 4, minus 9. But there is double minus here. It will become plus. Plus 5. So this is now 6 minus 2. This is 6 minus 4, that is 2. 2 plus 8, 10. Times 3 raised to power. Minus 4 minus 9. That is minus 13. Minus 13 plus 5. That is minus 8. So we can't simplify further. So this is our answer. Let's consider another example. We have 64 raised to power minus 1 over 3. In order to do this, we need to know the index of 64. and which we have given the other time. Index of 64, we have this, this, and this. So the best one to use is 4 over 3 out of the 3. So instead of this, I'll use 4 raised to power 3. I am using it because I have 3 here. Then raising to power minus 1 over 3 again. So according to the law, I can multiply. So 3 times 1 over 3. You see that 3 cancels 3. All you have left is 4 raised to, this is power. Then power of minus 1. That is what we have left. Everything here is power. It's on top. And 4 raised to power minus 1, as we have said, is 1 over 4. We have said if a number is raising to power negative, it is a reciprocal. This is 1 over 4. Another example, I have another one here, 0.25 raised to power minus 1 over 2. So we first need to transform this to fraction. This is a decimal point, and we transform it to fraction. We should have 25 over 100. This raised to power minus half. Now, we know the index of 25. So the index of 25 will give me 5 raised to power 2. I've shown you the other time. And the index of 100 is 10 raised to power 2. Then raised to power this minus half. By indices, we have given the other time, I said if they both have power in division and in multiplication, both of them, we take the power starting from this one raised to power minus half, then divided by this one again, 10 square, then raised to power minus half again. From that place, you see that 2 cancels 2. What we have left is 5 to the power of minus 1 left. Likewise, this cancels this. This is 10 to the power of minus 1. Now, I have this 5 to the power of minus 1 simply means 1 over 5 divided by 10 to the power of minus 1 means 1 over 10. And we have known this. We turn this division to multiplication. This will be 10 over 1. So 5 here 1, 5 here 2. Then our answer is equal to 2. Let's take another example. Find x. If x raised to power 3 is equal to 8, what we need to do here is write out the index of 8. And we have shown the index of 8 before. Should rewind back and get it. Index of 8 is 2 raised to power 3. So if the powers are the same, you can cancel out the powers if they are the same. So what we have left is x, and what we have left here is 2. In that case, x is equal to 2. Another one, 5 raised to power s minus 1 is equal to 1. So we want to find the value of x. Now, we need to recall that anything raised to power 0 is 1. So in that case, 2 raised to power 0 is 1. 3 raised to power 0, in fact, 5 raised to power 0 is 1. Since we are given 5 here, in that case, I can express this one as 5 raised to power 0. I can express it as 5 raised to power 0. So in that case, since the base are the same, either the powers or the base are the same, you cancel them out. Since the base are the same, we cancel the base. All we have left is s minus 1. All we have left here is 0. From that place, you take minus 1 to the other side. We have s is equal to 1. Now, let's take another one. 3 raised to power 2s minus 1 is equal to 1 over 27. Now, this is this. 1 over 27, with the index of 27 will quickly give me 3 raised to power 3. Now, we have known from the law of indices that reciprocal will give us negative fraction, negative power. So in that case, this thing becomes 3 raised to power, since it is reciprocal, to be minus 3. From that place, 3 cancels 3. What we have left is 2s minus 1 is equal to minus 3. Then here will become minus 3. When this one comes here, it becomes plus 1. So this is 2s is equal to minus 2. Then s is equal to minus 2 over 2. S is equal to minus 1. So that is our answer. Let's take another example. 25 raised to power minus raised to power 3 minus 2s is equal to 1 over 625. So we need to write out their indices, that is the index of 25 and the index of 625. So we need to write them out. The index of 25 will give me 5 squared. Don't forget there is a power here. This is 3 minus 2x equal to 1 over 625 will give me 5 raised to power 4. So I've given that here before. This is 25, this is 625. From this place, this thing simply means I should use 2 to multiply the powers. So that we have 2 times 3, 6 minus 2 times 2s, that is 4s. And by the law of indices, this one will become 5 raised to power minus 4. So from this place, 5 cancel 5. All we have left is 6 minus 4s for this side. For this side is minus 4. So we collect the like terms. 6, when this minus 4 comes here, it becomes plus 4. Equal to, when this minus 4s goes to the other side, it becomes plus 4s. This is 10. 6 plus 4 is equal to 4s. If you make s the same formula to be 10 divided by 4. 2 here, 5. 2 here, 2. Then s is equal to 5 over 2. I have this 5 square over this is equal to this. Without much stress, we can quickly cross multiply. You can see over 1. So in that case, 1 times this will give me 25 raised to power x minus 2. 1 times 5 square will give me 5 squared. From that place, we can find the index of 25, which is 5 squared raised to power x minus 2, then equal to our 5 squared. If you expand, 2 times s is 2x minus 2 times 4, 2 times 2, that is 4, is equal to 5 squared. From this, 5 cancel 5. All you have left is 2s minus 4 is equal to 2. Then 2s is equal to 2. When this one goes there, we have 4. Then 2s is equal to 6. S is equal to 6 over 2, which is 3. So you can practice the following question. So these are the questions. You can practice them. And also this, we should simplify this as well. So let's move to another interesting one. Yes, another important one is exponential equation. It looks like this. It's also part of indices, and we are going to explain it using this example. So to solve this, we need to recall the first law of indices, which says a raised to power m times a raised to power n is the same thing as a raised to power m plus n, and vice versa. This is equal to this. You will not see it. This is a raised to power m plus n. So in that case, this thing, according to the law, will become 5 raised to power 2s times 5 raised to power 1. According to this, then minus this. So from this place, let me write the 5 first. This 5 times 5 raised to power 2s. This 5 raised to power 2s, you will express it as this 5 raised to power s all square. The same thing as 2s. both of them are the powers, so s times 2 means 2s. So we have expressed 5 to the power 2s as this, minus 26 5 raised to the power s plus 5 equal to 0. Now you see, when you get to this level, you see that something is common, which is 5 raised to the power s. It is here and it is here. So in that case, you let 5 raised to the power s be equal to a certain letter. Let me use k. You can use letter of your own. So this thing will now become 5k. No, this is k, and this is power of 2 on it, on that k. 5k squared minus 26. This one is representing k now, plus 5 equal to 0. And this is a quadratic equation. So we have solved quadratic equation before. We have treated quadratic equation in our previous videos. So we're using 3 methods. So if you use any of the methods, pause the video and let's see if you are going to get it. So if you solve it, you will get k is equal to 5 or k is equal to 1 over 5. After you have solved the quadratic equation, so if you are on your own, you need to solve this quadratic equation and get these values. Now, if you bring back your k, this k is 5 raised to the power s. So instead of writing this k, because we let 5 raised to the power s to be equal to k, so let's rewrite it here. This will be 5 raised to the power s is equal to 5, or this k is 5 raised to the power s, then equal to 1 over 5. We can write this one as this. Ordinary 5 is same thing as 5 raised to the power 1. And we have said that 1 over 5 means 5 raised to the power minus 1. So from this place, we can cancel out 5. If we cancel out this 5 that is common, we see that s is equal to 1. Or if we cancel out this 5, we see that s is equal to minus 1. That's the solution to the equation. Let's consider another important example. So we have another example here. So it's still the same thing. We still use the same formula. This one will become 2 raised to the power 2x times, I'm using dot for times here, times 2 raised to the power 1. Then minus 3 into 2 raised to the power 2s plus 1 equal to 0. Let me write these two first. Times, I've told you, this 2 raised to the power 2s, you write it as 2 raised to the power s all squared, which is the same thing, minus 3 into 2 raised to the power 2s plus 1 equal to 0. So in this case, we can let a letter, 2 raised to the power s is common, so I can let a letter, let me use y now to represent 2 raised to the power s. So this equation here will become 2 raised to the power, this one is representing y, is 2y squared minus 3, this is y, plus this 1 equal to 0. This leads to quadratic equation. So you need to solve the quadratic equation. So by solving the quadratic equation, so you should get y is equal to 1 or y is equal to 1 over 2. So, but that is not where we are going. Where we are going is this. We have let y to be 2 raised to the power x. So instead of this y, you put the 2 raised to the power x there, which is equal to 1, or 2 raised to the power s is equal to half. In order for this to be equal, we want the base to be equal. So this 1, we have said, is same thing as anything raised to the power 0. So in that case, I'll choose 2 raised to the power 0. So 2 raised to the power 0 is equal to 1. Or, we know that this one is same thing as 2 raised to the power minus 1. From this place, 2 cancel 2, s is 0. Or, 2 cancel 2, s is equal to minus 1. So that is the answer. Now you can take this as a practice question. So you can practice this and this, and have a nice day.